class, so this is part 2 of our dividing polynomials section. So notice I have just divide these two polynomials. That's another way of saying 2x squared plus 2x minus 1 with a division symbol and then followed by x plus 4. Also the same as saying x plus 4 times what gives me 2x squared plus 2x minus 1. So you should be comfortable with all of the ways in which it could ask you to divide, and just make sure you know that they all mean the same thing. So it may be difficult to see what the difference is right now, but let's go ahead and divide them and see if we can see the differences from there. So we have a quadratic divided by a linear. So that means my answer should be a linear, right? Because a linear times a linear gives me a quadratic. So I should have a 2 by 2 box. I'm going to put my x plus 4 along the left, just like I've been. I'm going to put the 2x squared in the top left box. So now we're going to think x times what gives us 2x squared? It should be 2x. Once we know that, we can multiply back down and get that 8x in the bottom left box. Well, now we have 8x. We want to get 2x. So to get 2x from 8x, we have to subtract 6x. That's what's going to go in that top right box. Now we can figure out what needs to go at the top of that right column, because x times what gives us negative 6x? Negative 6. So now we can just multiply back down and we get our negative 24. Well, hopefully you notice this is different than what we've gotten before, because before we would have expected to get a negative 1 in that bottom right box. However, we're not getting a negative 1 in that bottom right box. So we need to think about, well, let's just double check everything, right? We have our 2x squared, that's good. We've got our 2x, because 8x minus 6x is 2x, so that's good. The only issue is that negative 24. So if we have negative 24, how can we get negative 1? Well, we could add 23 to it, right? So we can add 23 to it to make it negative 1. So that 23 that we're going to add is going to actually be considered our remainder. So these two functions don't divide perfectly. There is some sort of remainder with it when we divide. So how we would write that is 2x minus 6, remainder 23. And that's it. That's the only difference between dividing polynomials with and without remainders. So let's divide this cubic by this linear. So first of all, I know it's got to be a quadratic when I divide them, because a linear times a quadratic will produce a cubic. So I should have a 2 by 3 box. And so I have 3 columns to represent all of my terms in my quadratic. And I'll start off with 5x cubed. So x times what gives us 5x cubed? 5x squared. So now we can just multiply down the column and get our negative 10x squared. Now we have a negative 10x squared. We want a negative 13x squared. So what we have to do is we have to subtract 3x squared, so we get that negative 13x squared. So that's why that negative 3x squared will be in that box. Now, x times what gives us negative 3x squared? Should be negative 3x. Now we can multiply down the column to get our positive 6x in that bottom middle. Now we can move on to our x's. We have 6x, we want 10x, so we need 4 more x's. So we're going to have a 4x in the top right box. Now x times what gives us 4x? Should be 4. Now once we know that, we can multiply down and get negative 8. So again, you can see we're going to have a remainder here because we have a negative 8, but we need a negative 3. So always double check though. So we'll go back. We've got 5x cubed. That's good. Our negative 10x squared and negative 3x squared adds to give negative 13x squared, which is what we need. That's great. Move on to our x's. 6x plus 4x gives us 10x. Great. So the only issue we're having is with that negative 8. Well, what can we do to turn negative 8 into negative 3? We could add 5 to it. So since we're going to add 5, that means our remainder will be 5. So we'll write our answer as 5x squared minus 3x plus 4, remainder 5. Okay, not too difficult. So let's move on to the last dividing polynomials. And here we have a quartic divided by a quadratic. So what we should get is another quadratic, right? Because a quadratic times a quadratic gives us a quartic. So we should expect a 3 by 3 box because a quadratic has 3 terms in it, and our resulting answer should be quadratic, which has 3 terms in it. So we'll go ahead and list our quadratic on the left, and we'll go ahead and put our 3x to the 4th in our top left box. Well, x squared times what gives us 3x to the 4th? Should be 3x squared. Now we can multiply down that whole column to get our negative 3x cubed and our 6x squared, just like we normally would multiply. So we're done with the x to the 4th. Now let's move on to our x cubes. We have negative 3x cubed. We need negative 2x cubed. So what we can do is add an x cubed there. So our x cubed will go there in the top middle. Now x squared times what gives us x cubed? Should be an x. Once you figure that out, go ahead and multiply down that middle column, just like you normally would with any other box. Now let's move on to the x squareds. We currently have 5x squareds. We need 1x squared. So since we have 5x squared and we need 1x squared, we need to subtract 4x squared. So that's why negative 4x squared is going to go on the top right. So x squared times what gives us negative 4x squared? Should be negative 4. And once you've got that, go ahead and multiply down through that whole column to finish your box. So again, let's go ahead and check everything. We've got our 3x to the 4th, great. We've got our negative 3x cubed plus x cubed gives us negative 2x cubed, perfect. Our x squareds, our 6x squared minus x squared minus 4x squared gives us 1x squared. But uh-oh, our 2x plus our 4x doesn't give us 4x. It actually gives us 6x. And our negative 8 should be negative 5. So our remainder in this case is actually going to come from 2 parts. We're not only going to have the remainder with the negative 8, we're also going to have a remainder with the 6x. So what can we do to the 6x to make it be 4x? We can subtract 2x. What can we do with the negative 8 to make it negative 5? We can add 3. So we're doing 2 things here. We're not only subtracting 2x, but we're also adding 3. So our full remainder is going to be negative 2x plus 3, because we're subtracting 2x and adding 3. So we just put it together like a linear expression. So we would write our answer as 3x squared plus x minus 4, remainder negative 2x plus 3. So not much more complex, but you have to make sure that all of your 4th terms add up, all of your x cubed terms add up, all of your x squared terms add up, because sometimes your x terms might not add up. Sometimes your constant might not add up. Sometimes your x terms add up fine and your constant doesn't. But other times you have your x terms that don't add up right, but your constant does. So you just have to check everything and make sure that you're kind of fixing everything and making sure everything stays adding up to what it's supposed to be. All right, that concludes our dividing polynomials. I hope this video has been helpful to you. Here are some practice ones if you feel so inclined to do those. So these are a little bit more challenging, but feel free to do those, and you can always double check on online software to see if you're correct.